Okay, so I want to find the tension in the cable when I've got a 100-pound block, steady acceleration up the incline of 5 feet per second squared. So first thing we want to do is draw a free body diagram, okay? So we have this guy here, like so, okay? And I've got not just a P going straight up the incline, but also one at an angle of 30 degrees up like that, okay? I then have a weight of 100 pounds acting just like this. Now, let me take 2 seconds and talk about the coordinate that I'm going to use. I'm going to use X and Y. And I always set up my coordinates based on the acceleration. Okay, and I know my acceleration is going to be straight up that incline, so I'm going to set my x-axis straight up the incline to so only having an acceleration in the x direction. There will be no acceleration in the y direction. So because of that, I need to recognize that that 100-pound weight is 30 degrees off of my angled y-axis that I have there. I then have a normal force, okay? And then I have a friction force. Now, I know this guy is accelerating. I know it's accelerating up the incline, so my friction force has to be downward, okay? And that friction force has to be um, mu k n, so that's going to be 0.25 n, right? Because it is accelerating, okay? So again, I set up my axes knowing how my thing is accelerating. So I can then sum the forces in the x direction, okay? And that x direction will be the acceleration direction, okay? So in the x direction I have there, I've got p and p cosine 30, okay? And then I have the negative friction, negative 0.25 n, right? And then I've got the sine component of the weight. So that's going to be 100 sine 30, and that's negative because it's in the negative x direction. And this is going to equal the mass times the acceleration in the x direction, which I know to be 5. The mass is 100 pounds divided by 32.2 to get it into slugs, okay? And then I take that times 5 because I know I'm accelerating in the x direction 5. And that's why I set up my x-axis in that direction, because all of that acceleration is in that direction, okay? Conversely, you'll see what happens when I sum the forces in the y direction. In the y direction, I got my normal force, all in the y direction. And then I've got the component of my weight acting in the negative y direction. That's going to be minus 100 cosine of 30. And then a small amount of that p is in the positive y direction. That's going to be plus p sine 30. Now, this is why we took the axis and rotate it, because now mass times acceleration, there is no acceleration in the y direction. That makes this equation relatively easy to deal with. Okay, and what I have here is two equations, two unknowns, right? The only unknowns I have are p and n. Okay, so once I have this set up, now I can just two equations, two unknowns. I'll let you do that in your own, and you can recognize that the force is 43.8 pounds. So when drawing your free body diagram, okay, take 2 seconds before you start summing the forces and recognize how everything is accelerating and set your axes based on what you know about acceleration. That will make the math much easier for you having acceleration in only one direction.